Number 13, an airplane flies east for 200 miles before turning 60 degrees south and flying for 100 miles. What are the magnitude and direction of the airplane from its starting point? So we've done this with vectors. A vector will represent an airplane's flight really well. So an airplane, it says, flies east for 200 miles. So I'll say this is 200 miles to the east. And then turns 60 degrees towards the south. So this way is east, this way is south. So instead of continuing on that path, they make a turn. And so instead of going this way, it's 60 degrees towards the south. So something like this is kind of the idea. And they do this for 100 miles. So I'll make that one a little shorter like that. So this here is 60 degrees. And we're now heading southeast. And this is 100 miles here. Now, what are the magnitude and direction of the airplane from its starting point? So we want to know is from the starting point, if we would have just taken off on this path, where would we have ended up? So let's see here. When this plane takes off and it now flies, it basically flies on this path. What should be the magnitude and direction? And so we can kind of get an idea what we should be looking for. All of our angles should be south, something east, and I'm going to guess that these two are going to be out, and I'm just assuming that because this doesn't look like to be 70 degrees. We can check them, but it doesn't look like a good answer. Now the way to do this is we add our vectors up. So remember, we can write vectors, now that we know vectors and polar to work together, we can write it as a vector as an x comma y value or as an h comma theta value or an r theta value. We can write them as either way, and all we have to do is add these together. Now, I think the first one is easiest to write in terms of x and y because I know it's going 200 to the right, which is positive 200, and it's not moving up or down, so it's just comma 0. This one, it's going to be easier to write as an h because it's not like an x value, it's not a y value, it's angled, so we typically call that an h. So I'm going to write this one as 100, comma, and my angle is 60 degrees down. So we always, from the calculator, I have to put it from the x-axis, so it would be negative 60 degrees. What I'm going to do is I'm going to add these two vectors together and see what we come up with. So let's go over to our calculator, and we'll type these in. So the first vector was 200, comma 0, and I add this to the other vector, which was 100, comma, and we said negative 60 degrees because it's going downward 60 degrees. I'll hit the degree button. Now that I have them both in, I press enter, and it tells me my value. And this is giving me as an x and a y. So it'd be 300 to the right and 60 down. No, wait, messed up here. It's very important. Whenever you put an h and angle in the calculator, you have to put control book here. You have to tell the calculator this is an angle. So hit angle here. Now let's try this again. There we go. So now we actually turned out that we went 250 miles to the right, negative 86.6 miles downward. That would be the x and y value here. That's what I just found. This would be an x and y, 250, comma, negative 86.6. That's what that would be. But it doesn't ask for those values. It asks for the magnitude and direction. Now remember, magnitude is kind of like your h. So we're looking for h here. So the way to do that is we come back to this, and we're going to convert this to polar. So we go menu, 7 for vectors, go all the way down to the bottom and see vector again, and convert to polar. This will change this x and y to an h and theta. So I get 264.6 and negative 19.1 degrees. Let's write that down. 264.6 and negative 19.1 degrees. At this stage, I just realized I made a big mistake because I want to select this one. But here's what I messed up. This is going from the south towards the east, all of these values. This actually looks like is going to be the correct answer here, B, because that from the calculator is going from the east axis down. So from the x-axis down is negative 19.1 degrees. But we don't want it this way. We will actually want the angle coming from this way. which means I would subtract this from 90. If I did, I would get 70.9 degrees. And so B is actually the correct answer. The thing about the calculator is it'll tell us the miles the best. So we could have seen from here, oh, 264 is the right value, and gotten that. So again, what I do, I wrote out the two values as either x and 8y or h and theta. And the thing I messed up in the calculator is we need to put the angle symbol there. So I'll throw that in. And once I add that up, it'll give me my x and y, and then you just convert it to Fuller.